everybody, what is up? Welcome to the Data on Kubernetes community live stream number 142. It's incredible that we're getting to these super high numbers, getting close to that 150 point. Very excited about that. We just celebrated our 2nd year anniversary with an in-person meetup in San Francisco. And speaking of in-person meetups, we'll be doing another in-person meetup next week in Mountain View. I will share the link to that. We've already got a couple of talks confirmed, waiting for other ones to be coming in. Other things in terms of news, it's no coincidence that our speaker today will also be giving a talk in KubeCon. But just remember, folks, we have our CFP open for DoK Day. I will leave the link here. That will be open until the beginning of September. So get those CFPs in there. If you're not sure about whether it's the right fit or not, please let us know. Reach out on Slack. Be happy to help you get that properly set up so that it's not a vendor pitch, directly focused on Data on Kubernetes community related topics. So like I said, if you've got questions about that, if you're interested in more in knowing about what we're going to be doing on October 24th in the DoK Day in Detroit, please let us know. But like I said, we celebrated our 2nd anniversary, not that long ago. And as I was just talking to today's speaker before we're getting started, initially we got started as a community because of this doubt, is Kubernetes even ready for stateful workloads? Have we sort of, crossed the chasm? Are we there yet? So I think it's very fitting that we do have a speaker today from Google. As we all know, Kubernetes was born from Google, from Borg. And he's also joined by another person from Google. So without further ado, I would like them to introduce themselves, Peter and Akshay. Whenever you're ready, turn on your mics and say hello.
Great, thanks for the intro, Bart. Hi, I'm Peter. I'm a senior software engineer at Google, and I work on GKE Kubernetes. My main focus is on improving the environment for stateful workloads and helping customers run safe workloads on Kubernetes.
Very good. Well, you've come to the right place. That being said, Akshay, could you introduce yourself?
Yeah, hey everyone. My name is Akshay. I'm super excited to speak with the community today. I'm a product manager, and I have the same charter as Peter, trying to figure out how to make stateful applications work better with Kubernetes.
All right, perfect. Well, that being said, I'll let you take it away, folks. As usual, please get your questions in the chat. If not, if you'd like to continue the conversation on Slack, always willing to do so after the live stream's over. But that being said, Peter, take it away. Oh, Peter, you are muted. It's okay. It's 2022 and nothing gives us more problems than Zoom, so don't worry about that.
Okay, I might ask Akshay to present the slides.
That's all good.
There's this bizarre bug that I have where if you present, you cannot talk. So just a sec.
That's all good. That's good. The thing is, once again, we're talking about data on Kubernetes, but slide sharing and microphones and cameras can still give us plenty of bugs and issues, so no problem there whatsoever. All righty.
So yeah, I might join via audio on my phone.
That's okay.
The demo portion.
Yeah, that's okay. That's okay. Yeah, we can connect as many ways as possible. No worries.
Cool.
Yeah, just give me 1 second. I'm just going to pull up the slides.
That's okay.
Sorry about that.
That's okay.
Yeah, I was worried this would happen because in some of the SIG meetings, this does happen to me. So it's kind of like either my slides need to look beautiful, or I need to speak beautifully.
Get that both. That's okay. It just gives you the opportunity to focus on one thing more than another and make that work. Anyway, now we can see it. It looks great.
Awesome. Okay.
Yeah.
Great. So yeah, everyone. So we're going to be talking about Kubernetes cluster upgrade strategies today, and best practices for your stateful workload. So addressing this question of, is Kubernetes ready for stateful workloads, and specifically focusing on upgrades. How do we make sure that your application remains available? So next slide, please. So just a brief agenda. We're going to be talking about why upgrade. So, the benefits of upgrading, why it's important to keep your application and your environment up to date. And as we know, upgrades are an essential element of running a modern application in Kubernetes. Stateful workloads and upgrades. So upgrading stateful workloads has been historically challenging, more challenging than stateless workloads. So we'll discuss some of the reasons why. And then we'll talk about some strategies for both node pool and control plane. So 2 dimensions we need to upgrade. And then finally, some takeaways from this talk, how to maintain your availability and what trade-offs you need to make when choosing a strategy. So next slide, please. So why upgrade? So let's go back and revisit the Kubernetes version lifecycle. So this has changed over the years, but it's settled on around a 4-month cycle for releases. And here we're talking about the minor release cycle. So it takes, it goes through feature discussion, feature freeze, release branch creation, and then code freeze, and then bug testing, and then finally code freeze ends and a release is created. So this translates to roughly 1 release or 3 releases a year. And so that's for the minor releases. And then there's also patch releases that typically occur about once a month. And if there's critical bugs, that may cause a more frequent release. So there may be actually more releases than the normal cadence. But a typical cluster upgrade cadence is around 10 times per year. If clusters include maintenance events, such as during business critical windows like Black Friday, Cyber Monday, or the winter holiday season in the Northern Hemisphere. So just emphasizes that the treadmill of Kubernetes updates is very continuous, and clusters do need to upgrade frequently to stay up to date. Next slide, please. So beyond this treadmill of Kubernetes upgrades, what are the other reasons why upgrades are important? So it helps you maintain a modern and a protected application. So if your application, you want it to be up to date, you want it to have access to the latest features, maybe even not necessarily using them, but having them available or being able to upgrade on demand if there's a new feature that you need to use. So features are introduced in Kubernetes through stages, and they're usually available as alpha features first on new minor versions, and then progress to beta and GA in subsequent minor version releases as API surfaces and functionality improves or matures. For example, the stateful set max unavailable, that enhancement was introduced in 1.24 in alpha. That enables stateful workloads rolling upgrades or stateful set rolling updates to proceed more quickly with parallel updates. Next, version skew. So this is a policy of Kubernetes, but the version skew between the control plane and the nodes version is only maintained for up to the 2 previous node minor versions. So very quickly, if control planes keep updating to the latest minor, the nodes will fall out of support within about a year. So they don't need to be updated like in parallel together, but maintaining upgrades for both nodes and control planes is very important. Finally, security compliance. So organizations, this is important for data governance, achieving secure data governance. So as security standards become more mature and ubiquitous, organizations may find themselves in a position where they need to retain modern, up-to-date regulatory standards. So, for example, PCI for the retail industry, HIPAA for healthcare, and FedRAMP for companies that are working with the US federal government, are required to upgrade security patches within a certain period of time once they're released in order to maintain compliance. And then finally, patch support. This is kind of similar to version skew, but minor version patches are only maintained in support for about a period of a year. Officially, it's a support period of 14 months. And after this, minor versions will not receive any more patch versions. So if you're running an older minor version, there won't be any up-to-date security backports or bug fixes. So again, this kind of ties into the regulatory compliance. So yeah, Kubernetes users, expect a reliable, consistent upgrade experience. It means data must be continuously available. And let's go to the next slide. So, on Kubernetes, we see a lot of data SaaS companies leveraging Kubernetes and using Kubernetes offerings to reduce the heavy lifting of the upgrade process. So, if you're able to offload a lot of these undifferentiated tasks that require a lot of work, allows your company and organization to focus on your key differentiating elements, the unique pieces that make your business successful. Next slide, please. So let's talk a bit about what actually happens during an upgrade. And this is kind of a rudimentary diagram of a Kubernetes stack. So on the left side, we have a few different dimensions. So we have the Kubernetes cluster, which your application runs on. And the cluster is composed of two major pieces, your control plane and your nodes. And within that, there's your VMs, which are your nodes, your control plane VMs, the versions of software that Kubernetes is running, so your node version, your control plane version, as well as your operating system and any library dependencies that Kubernetes needs. And then lower in the stack, we have compute and storage infrastructure, networking infrastructure. So all of these pieces are maintained by different owners, a typical application. So at the top, we have an application developer who's responsible for the application, maintaining it, updating the business logic of the application. And ideally, the abstraction of Kubernetes should enable the application developer to only worry about this application, just the business logic, and streamlining their business. Underneath this, we have the Kubernetes administrator, who's responsible for setting up and managing the Kubernetes clusters on top of a cloud platform, controlling cluster-wide features like upgrades, timing of upgrades, operating system upgrades. And then beneath this, we have the cloud platform, which is responsible for setting up the compute and the storage infrastructure, maintaining the networking, and maintaining the underlying infrastructure. And so we can see this as like a multi-layered stack. So your compute, everything, networking infrastructure is maintained by your cloud provider. And then, going up the stack, a lot of these pieces just are built on top of each other to make sure your application stays up to date. And one key part about the application that isn't dependency between Kubernetes and your application that isn't really captured on this slide, but is important to mention for the next discussion is your application also depends potentially on an interface for Kubernetes. So the control plane version and the node version may be a dependency of application. So whether that's an operator, your application is orchestrated with an operator that communicates with a control plane, so API server, or an application that relies on certain system features like a kernel feature on your node VM, the application does need to maintain compatibility with the Kubernetes cluster it's running on. And, oftentimes APIs are stable if you're using a lot of the core APIs in Kubernetes. There isn't much surface changes that occur when there's Kubernetes version upgrades, but this is something that is needed to call out, especially as APIs do deprecate in new versions if you're using beta, for example. Okay, next slide. So just what this talk is focusing on, we're really going to be talking about what's going on with what the Kubernetes administrator controls. So your control plane version, your node version, the maintaining the VMs and updating the operating system. So on your cloud provider in GK, for example, the VM infrastructure, so your hypervisor stack, networking stack, network upgrades, those are all handled as part of the compute live migration process. And then for your Kubernetes upgrades, typically these are bundled with operating system updates. So there's typically a Kubernetes release bundle. So you don't need to necessarily match up exactly what operating system version with your Kubernetes version and manage those dependencies between those two systems. Okay, next slide. So let's just talk about the upgrade dimensions here. So what can you control, or what do you need to be concerned about as you're upgrading? So number one is application compatibility. I mentioned this before about this dependence on, say, an operator depending on a beta API or some API server implementation. So the key part here is ensuring your application is compatible before upgrading Kubernetes. And then we have node upgrades, so upgrading the operating system, the dependent libraries, and the Kubernetes software of your cluster's data plane. So what your application, the VMs, the nodes that your application runs on. So this is upgrading kubelet or any add-ons on the nodes such as CSI drivers. And then finally, we have the control plane. This is upgrading the operating system and the software on your machines that Kubernetes control plane runs on. So this will be components like etcd and API server in the control plane. So next slide. So what are the key concerns? So split this into kind of 3 areas of concern for upgrades. And if I can draw an analogy to the CAP theorem for distributed data stores, the right best practice really will depend on your business's needs. So you can kind of choose a point in this Venn diagram where you can achieve higher availability at the expense of maybe increased cost or increased speed, and vice versa. If your application is more fault tolerant, you can potentially decrease the speed or increase the speed and increase the cost. So just to recap these, application availability is just ensuring your application remains available to clients and there's enough resources to maintain your level of capacity to handle system load. Cost, upgrades can involve CapEx increases for on-demand or over-provisioning. So strategies that involve that to ensure there's enough resources for your application. However, these strategies can reduce OpEx costs and decrease your overall risk. So when looking at costs, the total cost of ownership is something that should be evaluated and calculated when choosing a strategy.
One question real quickly, Peter, from the audience. Got a couple of questions from Ravi. So does a Kubernetes upgrade occur without pods downtime? And an additional question, what is the method to roll back an upgrade?
Yeah, good question. So we'll talk a bit about rollbacks in later slides. But for the first question, so pods do need downtime. So I guess the model for Kubernetes upgrades, at least it hasn't been, like if you look at VM migrations, like typically VM state is able to be live migrated to another VM. And this happens with a very minimal period of time of downtime as memory and state is transferred over. For Kubernetes, however, the model is to reschedule a pod to a different node resource. So Kubernetes treats pods as being units that are ephemeral and can be terminated and rescheduled. So there is some downtime that's incurred in a pod, and that's why we look at the overall availability of the application as a whole, rather than the availability of individual pods when looking at upgrades. And then, yeah, for the rollback question, we'll discuss how rollback works for different upgrade strategies when we look at how to upgrade the nodes.
All right, perfect. Thank you.
And then, yeah, final point here. So speed upgrades can result in reduced availability. So it may limit the administration of the cluster during the upgrade. And the speed at which an upgrade progresses can reduce availability if you take multiple resources down at the same time you're upgrading in parallel. And next slide, please. So let's look at node upgrades first, and we're going to start with this concept of surge upgrades. So surge upgrades work by leveraging 2 controls. So let's think about your nodes as a group of nodes. We can call that a node pool, and all of these nodes are running an older version. You want to upgrade these nodes to be on a newer version of Kubernetes. So there's 2 controls that the user has, and this is common to both GKE and EKS. They follow this pattern. Number 1 is your surge threshold. Number 2 is your max unavailable. So what is surge threshold? It's the threshold at which you can over provision your node pool to increase the resources. And this enables you to provision nodes that are on a new version of Kubernetes. So that, when your pods are rescheduled from your old nodes, they're able to reschedule to these surge nodes right away. And then number 2 is your max unavailable. So this controls how many nodes you can remove from availability at the same time. So this enables you to control the speed and also enables you to control the amount of resources you have available to your cluster. So depending on how these parameters are tweaked, you can kind of achieve different levels of these 3 key concerns I talked about. So Application availability. Surge upgrade is often suitable for fault-tolerant workloads. So you can control your availability by specifying max unavailable. So if you increase max unavailable, that will increase the number of nodes that may be down at one point in time. So if your application can support that, support reduced resources or availability, then that's an option. For cost, it's very cost effective. Say if you're using a low surge threshold, you can effectively maintain the cost of your cluster during the upgrade. So there isn't much of a need to over-provision resources and over-provision nodes during the upgrade window. And then finally for speed, depending on your application availability and the cluster resources, surge upgrades can upgrade multiple nodes at the same time. And because of this, pod disruption budgets and node affinity are critical to ensure that any unexpected disruptions, so say if a node crashes, maybe you have a zonal outage in your cluster, ensuring that these disruptions don't compound on the upgrade process as you're upgrading nodes.
Quick question from Abhijit. I think you kind of addressed this. He's asking, can I over provision just before the upgrade? Would that be a good practice?
Yeah, so you can leverage the surge threshold to do that. So you could over provision based on like the speed of upgrade just before the upgrade, and it enables you to kind of reduce your cost by doing that. So that is a best practice. It also lets you ensure that there's enough capacity in the particular region you're running in before you upgrade. Okay, yeah, and that kind of brings us to our next upgrade strategy, which is blue-green upgrades. So this is a bit of an animation showcasing surge upgrades here, where you take down a pod, you detach a disk from a node, and then you either bring up a new node or perform service on that node, and then reverse the process of teardown. So you attach the disk to the node and then bind the pod. Okay, next slide. So blue-green upgrades. Yeah, blue-green upgrades work by pre-provisioning all of the resources you're going to need. So you can think about this as taking surge upgrades to the extreme, where you say you have a blue node pool, and that's your old version. You create a new green node pool, and you over-provision provision the same amount of nodes that you did have on the blue node pool. So what this does is it effectively doubles the resources. But it enables you to have a lot more granular control over your application migration and your upgrade. And rather than moving specific nodes at a time, it enables you to move application entities at a time. So since your blue node pool sticks around during upgrade, if there is an issue with running your application in the new green node pool, you can roll back a lot faster because those resources are still sticking around. So actually, if you can click through this little animation, I'll just talk through this. So you see here, we're evicting a pod from a node, and then the pod is being terminated, detaching the disk. And then if you click through again, yeah, we're rescheduling this to a new node in a different node pool, but keeping that existing resource in the blue node pool around. So as I mentioned, yeah, application availability, you have granular control over migration. And you're able to like move your application around faster because your resources your previous existing resources are still there. For cost, there is this increased cost. For speed, you can migrate as slow and controlled as you want, and oftentimes users will use a period of soak time to migrate a workload or migrate a node pool from blue to green, and then let it sit there for a period of time to make sure that the application is stable and doesn't need to be rolled back. So it enables you to kind of either canary a portion of your application or a portion of your node pool, and then if everything's green, move it over. Okay, next slide. So just some takeaways here, comparing and contrasting the key concern areas between surge upgrades, blue-green. We have higher application availability for blue-green at the expense of potentially increased cost, increased speed. Okay, and let's talk about control plane upgrades now. So control plane upgrades, they're inherently, Kubernetes maintains API versions for each minor release. And the API schema may change with new minor versions. So when upgrading the control plane in an existing cluster, control plane upgrades are inherently only forwards compatible. So keep that in mind as we talk about the strategies here. Next slide. So surge upgrade. What is a surge upgrade? Surge upgrade is, it's similar to the node pool surge upgrade, but enables you to effectively replace the resources in your control plane with new versions. So consider a scenario where you have a high availability control plane setup. Maybe you have 3 control plane nodes that are running your control plane. So in this case, you can upgrade 1 node at a time and still maintain 2 resources. So in this, you can limit your disruption in this case by still always having a majority of your control plane available. If you're running a configuration that has a single tenant or a single control plane VM, then you may run into some disruption for your control plane. This doesn't affect your data plane, however. Your applications should remain running for the brief window of time that your control plane updates. But this is, as I think historically, there's this kind of message that oh yeah, if your control plane is unavailable, that's okay. Control plane can have higher unavailability than your data plane. But control plane updates, control plane disruptions are actually quite disruptive. As operators have increased in usage, prevents your operator from communicating with API server and taking action on your workloads, prevents you from performing administrative tasks on your cluster. So maintaining the availability for control plane is becoming increasingly important. For cost and speed, this is a very cost-effective solution because the cost effectively remains stable as you increase your cluster size. And the speed is very fast. If most control planes high availability have max 3 nodes, or 3 VMs, so upgrading 3 VMs is pretty quick.
Oh, got another question? Actually, a couple questions. First one's from Saurav. So, hi, what would be the best practices in case of stateful sets and related volumes when upgrading? Do all these strategies work for stateful workloads too?
Yeah, so for stateful workloads, I think we're probably just talking about the, mostly talking about the node upgrades. But what you can do is leverage, for the surge upgrades, make sure that you're following best practices for stateful upgrades. For stateful sets, like managing your pod disruption budgets, managing your node selector, your pod affinity, making sure that your application is well suited for disruptions in general. Like say if there's a VM that crashes or there's a network partition on a particular zone. So if you build modern applications that do support fault tolerance, these strategies will work for stateful sets and stateful applications.
Okay. And a question from Richard. What parts of the cluster are actually not replaced in the upgrade? Would it be more like a migration versus upgrade in place?
Yeah, so if we look at just nodes, like the actual nodes are being replaced. So you are taking down VMs and you're creating new VMs with new Kubernetes versions. Same thing for your control plane, but effectively your state is retained due to your etcd permanence across your control plane upgrade. And that's kind of an interesting question because we're going to talk about a strategy next, which does involve more of a migration than an upgrade, but it is a control plane blue-green upgrade strategy.
Okay, great.
So yeah, the other strategy for control plane is blue-green upgrade. So what is that? It's similar to how we had node pool upgrade with blue-green. We'd actually create a new node pool, and we had 2 node pools running at the same time while we're upgrading. It enables us to roll back from green to blue. What control plane upgrade or blue-green upgrade allows you to do is create 2 clusters and migrate your application between the clusters. So you're effectively running a blue cluster, a green cluster, and migrating your workload across them. So this enables you to migrate your application in a more granular way, like migrating your application rather than upgrading the version of the control plane in your cluster. But effectively, you are moving to a new control plane version. And the key advantage of this strategy is that there is a path to having a safe minor version rollback. So as I mentioned 2 slides ago, the Kubernetes control plane is inherently a roll forward strategy. It doesn't allow for rollback. And the reason is because there is API versioning that happens with your etcd and particular storage schema, and rolling back is not supported. But if you're migrating across workloads and your application still leverages the same APIs across control plane versions, then your application can actually maintain availability in both clusters. As for cost and speed, this strategy, it is going to increase with increased cost for control versus surge upgrades for control plane, because you are creating a separate cluster. So you're effectively duplicating your control plane cost and pre-provisioning your other cluster. But the advantage you get is, you can move over applications, have a lot of granular control. You can control the speed of your migration as you need. So next slide. So I'm going to walk through a little bit of a demo here, but I've created this CAP 3335 that enables introducing some building blocks, the stateful set API, to enable stateful set replicas to be moved across clusters. And this leverages the multi-cluster services for this demo, which is introduced in 2020 with CAP 1645, to allow applications to maintain connectivity across clusters. But this building block, effectively enables different service mesh strategies to be used to maintain connectivity across clusters. So this demo I'm going to showcase, we're going to showcase the migration of a Redis instance moving across clusters. And thanks to Ben Coleman for creating KubeView, because I'm going to be using KubeView to show a visual demo of this strategy in action. So I may need to join audio on my phone.
That's okay. It's been nice. It's been nice watching you up until now, Peter, but that's okay. Whatever works. This is the first time we've done 142 live streams, and we're making history. This is exciting. Yeah, you join, you get in however you need to, and whatever's most comfortable. That's fine.
Okay, sounds good.
Yeah. While he's rejoining, folks, keep the questions coming. Seeing really, really good stuff. And as always, if you want to continue the conversation later on Slack, you can definitely do so with Peter, as well as all of the guests who we've had here and on our live streams. So it looks like we've got Peter again now, but we're still seeing your camera, if that matters. And you are muted. That's all good. Later on, if we have time, we may want to ask a question that came up with one of our other members from Plural about stateful sets. What's some of the stuff going on there? Let's see though. Peter, do we have you back with your audio now? Not quite.
I can answer any questions
Okay, good. I guess, well, one of the things that while he's getting that set up, so he did mention, mention operators, and this is a big topic in our community. So Akshay, I just wanted to know in your experience, what your experience has been like with operators. For a lot of folks, it seems that as of right now, it's sort of the primary go-to solution for running data on Kubernetes. Just want to know your experience with it and where you might see this going in the future.
Yeah, no, absolutely. So operators are super, super helpful. So if you look at the lifecycle of stateful apps today, it's super easy to like provision a stateful apps. There's many like Helm charts. There's a lot of easy ways to get up and running. However, what we hear from customers is the hard part of stateful applications is the day two operations, not the day one. You can get provisioned easily, but maintaining and managing availability as upgrades, as Peter is saying, that's a real problem which you have in your day-to-day life. So you have to like factor in all of those problems early on, and it's not a later problem, so you can't kick that problem down the road. And that's where operators do encapsulate all of the best practices of upgrades. They're kind of aware of the life cycle of Kubernetes and all of the stuff Peter was talking about. So they have all of that business logic encapsulated in them. However, the nuance with operators is, again, there's a qualification of operators. You need to be careful on who's supporting the operator, who's the author of the operator, because that is software that has its own life cycle. So if you're taking like a business critical dependency on it, you need to vet it and make sure that you have either a support contract or it's like a vetted open source project that you are comfortable with the maintainers of the project and or you have the expertise yourself to contribute any upstream change. So that's the key nuance. But yeah, in general, those are the gotchas you need to think of. But operators are great, and we do see customers increasingly use operators.
Great points there. And like you said, it as a piece of software, who built it, what's the support, do we have direct contact with the maintainers? You're sitting in front of an end user or customer and they have access to financial records or medical records or things like that. They're going to be wondering, I'm putting the data in my hands of a reliable source. Like you said, these are questions, these are things that can be looked at and to provide that transparency and confidence so that customers feel more comfortable. Anyway, thank you.
Well, great. Okay. So
yeah.
I'm finally back on the call. Can everybody hear me?
Yeah. You're doing great.
Okay, perfect. Awesome. Okay, yeah. Just wanted to double check. You can see my screen as well. I'm just on a different view on my desktop.
We can see your screen, Peter.
Yep, everything is good.
Okay, perfect. All right, so let's get started with this demo. So what I'm showing here is two clusters. So on the left, we have a cluster that's running Redis in a namespace. There's 6 replicas, and it's each of the replicas, we're using stateful sets, we're using persistent volume templates. So each of these replicas has its own storage. And in this case, this is a cluster running on GKE, and these are persistent disks as PVs. So I'm going to kick off a migration here, and we're going to see this application migrate across to this cluster that's on the right. That's currently just a service. There's no stateful set running in it yet. And we're leveraging multi-cluster services to maintain connectivity between replicas of these stateful sets running on different clusters. So let's see here. I'm just going to showcase. This might be kind of small to read, but it's just a migration spec that basically says, take this stateful set and migrate it from one cluster to the other. So let's kick this off here. And watch what happens. So what we're seeing here, first, we've migrated all of the data references over. So that's the PVs and the PVCs. So the PV definitions in the cluster on the left, those are pointing to underlying persistent disks. In both these clusters, they're in the same region, they're in the same zone. And so they're able to access the same persistent disk and the same network-backed storage. So we've just migrated over the PVs, PVCs, and now we're starting to orchestrate replica migration. And this is using that KEP 3235 that enables for a stateful set to be split into these slices. So right now, as we look on the left, we see replicas 0, 1, 2, and 3. And on the right, there's replicas 4 and 5. And so the upgrade to the stateful set API enables you to take a slice and trim down a stateful set. So both clusters own a partition or a slice of this stateful set as it's being migrated. And the way that this replication works is that, or the orchestration works is that as replicas move, the orchestrator waits for these replicas to become healthy before moving on to the next replica. So the orchestration does movement one pod at a time. So it's kind of similar to a rolling update on a stateful set today, if you were to upgrade the application. But in this case, we're really just upgrading, the applications remain the same, but it's just moving ordinals over, replicas over from one cluster to the other. And you'll notice that, these storage references, PVs, PGCs, they're the same across the clusters, but we're only referencing one of these references at a time. So we're, detaching the storage reference from the cluster on the left, and then having it being used by a replica on the cluster on the right.
Sorry, just a quick question. Someone from the audience, Waleed, is asking, which KEP was it again?
This is KEP 3335, and I can post the slides and also the link.
Okay, perfect.
To the KEP.
Great.
In the DoK Slack afterwards.
Excellent. Great. Thank you.
Great. So yeah, this is kind of finishing up here. We see everything migrated over, and the final replica is just spinning up and joining quorum with the rest of the Redis replicas. Great. Okay. So I'm going to stop sharing, and then we'll just go through kind of some of the takeaways of what we discussed, and then open the floor for questions.
All right, so in our four-way transitions, now I guess Akshay will be sharing slides again. Yes, excellent.
Okay, so let's see, just to recap, looking at the control plane upgrade takeaway slide, there's 3 dimensions. So I think the biggest one to call out here is the application availability. So yeah, for surge upgrades, there's really no way to roll back. Once you've started the cluster upgrade process and you're upgraded to a new version of the control plane, you can't roll back to a previous version. Whereas with blue-green upgrades, there's this existing cluster that still is there that you can migrate your application back to. And then obviously this is a trade-off of speed and cost. So it's really up to your upgrade strategy and kind of the criticality of having these additional tools available to you. So finally, takeaways. So yeah, a lot of this, it's difficult to really recommend a best practice that kind of encompasses every case. Best practices really are the appropriate trade-off of business requirements between your availability, what you need for business, the speed, and the cost that you choose. Modern applications should be updated consistently and often, for some of the reasons you described at the beginning of the talk. And Kubernetes does have the tools to support safe, stateful upgrades today, whether that's through these existing strategies of node pool upgrade, control plane upgrade, maintaining availability for access to your control plane. But the community is building new tools to increase its margin of safety even further for KEP 2235 and some of these control plane, blue-green control plane upgrade strategy. So with that, I think I'll stop sharing and just open the floor for any questions.
Okay.
Yeah, it was great to present and kind of demo this building block that we're working on.
No, very, very cool. Excellent demo. Nice presentation. Good to see so many folks getting, questions and ideas out there as well. I had a question when earlier, but I wanted to wait to the end. We had another speaker from Google, actually about a year ago, Yuri Grinstein, who spoke a lot about, the importance of SLOs, SLAs, SLIs. When going through these upgrades, are these things that, Kubernetes stakeholders, such as an SRE team or infra folks, sysadmins, or also DBREs, we see these different kinds of roles. When they're going through the upgrade process, would it be necessary to revise or perhaps make adjustments in some of those, in SLOs, SLAs, SLIs?
So yeah, for the most part, if your SLAs, SLIs are within a threshold of tolerance, like you should be able to maintain those during the upgrade process. Like one example I can think of is, if you're making sure that you over provision for resource spikes during particular time windows, you may want to maintain that SLA or that SLI. Like, you have a certain amount of free capacity for your nodes. Strategies that can allow this, like, maybe it's time locality. Maybe you're moving your upgrades to occur at a period of time where there's less traffic to your infrastructure application. So you can kind of experiment with those sorts of things, but ideally, like the tools of pod disruption budgets, of pod readiness probes and liveness probes should enable you to kind of have a way to do this safely.
And just to add to what Peter said is, as Peter was saying, there's tons of tools in Kubernetes. We see customers be super successful with stateful apps and Kubernetes. I think the nuance with stateful apps is also organizational. So usually you have the Kubernetes admin and the application developers, and they go about their own way. It's pretty transparent as the cluster and the nodes get upgraded underneath them. It's a stateless app, it just gets upgraded. There's no disruption. There's no like conversation between the two pretty much because it's completely transparent. Whereas a stateful app like the SLO and the SLA can be like, how long does Redis take to reach quorum? How long does Kafka take to reach quorum? So all of these are nuances that both teams have to talk together a little bit more than they would with the world of stateless app. Like in a stateful app, you want your Kubernetes administrator and your application developer to kind of speak a little bit more to each other to kind of figure out the right set of knobs, because the knobs are there. There's plenty of knobs. It's more like an organizational gap where, hey, you want to just talk more to your application developers and ensure that you're setting the right gap, because the expertise is spread across these two like different realms. It's not just one realm. So that's the nuance and the practicality of being successful with stateful apps.
Great point there. And like you said, as much as we're talking about the technical side of things at an organizational level, how does this look? Who is where does the ownership reside? I think that's a really strong point that we've seen in with other live streams that we've done, but we can never really leave that out of the equation here when we're talking about these issues. Another thing that came up as a question from one of our audience members: are there any challenges related to leader election during control plane upgrades that we should keep in mind?
Yeah, so if you're running a high availability configuration for your control plane, the Kubernetes should be able to like handle that for you. So in terms of, you're removing one of your, say if you're running 3 VMs in your control plane, you take one down. The leader election process that's built into the Kubernetes API should enable that for you for etcd leader election. I know that a lot of other components these days do have leader election built in. So different controllers in Kube-Controller Manager are able to also leverage leader election. So I think it really depends on the infrastructure you're using, like your cloud provider, and the settings that you can use for maintaining high availability during control plane upgrade.
All right, good to know. Excellent. Another thing that I wanted to ask, just as sort of a general question that we try to ask all our guests, both of you, interacting with customers, and when they're faced with this, sort of situation, and maybe they've heard or they've read, don't run stateful workloads on Kubernetes, keep the data outside, just do everything statelessly. When you're approaching that conversation, and you do have to explain some of these things regarding, of course, there are going to be trade-offs no matter what. what are the key benefits that you find that they seem to find, or that they seem to detect, to say like, okay, we are going to do this. We think we're ready for this. We see the value in here. What are the things that are coming up in those conversations? And what would you recommend to folks that are having those conversations or will be having those conversations with customers in the near future?
Yeah, I can take that, Peter,
Okay.
if you don't mind. So I think so there's, we've been thinking about this, Peter and I just talk about this all the time. So just to kind of lay the land out, there's kind of like 3 ways customers can run stateful apps even on Kubernetes. They can do it themselves, like they can take the container image of Redis and run it themselves as a stateful set. That is like the DIY version. They can use an operator. For example, there's many operators that even have support contracts that kind of makes it even more managed. Like, hey, I have like a not fully self-managed in DIY, but I have a contract. For example, Elastic has an ECK operator that helps you like simplify operating Elasticsearch on Kubernetes. And then there's the fully managed solutions, right? You have the SkySQL, which MariaDB has. You have Databricks, who runs their own fully managed solutions for stateful applications. They themselves are also running on Kubernetes. So you have this spectrum as a customer to choose around, how much you want to manage yourself versus how much you want managed for you. And what you see in Kubernetes is you have the whole spectrum. Like you have the fully managed services running large multi-tenant stateful applications. For example, SkySQL is MariaDB SaaS. So you as an end user don't have to do anything, but that SaaS runs on Kubernetes itself. And if you want to DIY and manage more control of the stateful apps, you can also do it yourself. Now, coming to your question of what benefits you see for a customer, operating stateful apps on Kubernetes, I think the biggest one is as customers have gravity, it's kind of like the sun gets more gravity and bends space-time. So Kubernetes gets more gravity in an organization, and it kind of sucks in like the other applications into its kind of realm. And there's obviously benefits to that because you have like a core team which has economies of scale in their expertise, because they understand Kubernetes and there's no like silos in expertise or operating infrastructure, stateful differently, stateless differently. It all becomes common knowledge of using stateful applications. So that's one of the biggest benefits we hear. And then the second benefit is, of course, you get portability. You can port it across your on-prem to your cloud infrastructure easier. That's like the benefits of Kubernetes itself. So that's one of the 2 main reasons we hear in terms of expertise and in terms of portability of why customers use stateful apps on Kubernetes. Now, finally, like the last part, which is some of our conversations with our internal SRE teams at Google, who run stateful apps on Kubernetes, they said they get a lot out of Kubernetes. Actually gives you a lot out of the box. The whole aspect where Peter was talking about modern apps, there's like built-in orchestration. You're always saying on upgraded infrastructure. All of these things really matter to customers. So like if you speak to the internal SRE teams at the before and after of running on VMs and Kubernetes, they're like, I have so much more benefits. I just needed to set the right knobs and invest in setting the right knobs and learning a little bit of Kubernetes. And now my apps are modern. It's always patched. I'm always compliant. I don't have to care about anything because it's all managed. So that management is aspect which Kubernetes brings to your stateful application is the third, actually most important. What we hear from customers is a fixed cost of training, of learning stateful apps in Kubernetes, and then the ongoing variable benefits is a lot more. So it really pays off over time.
Wow, fantastic answer. Very, very concise. And as you said, looking at those different elements. And the last one too is that we have heard from on different occasions about leveraging these built-in features that, like you said, come out of the box with Kubernetes. Other factors that get involved there as well too, as you mentioned, the gravitational pull. Let's have everything all under one roof rather than having things in separate areas. A sort of drive to do that for some reasons for operational simplicity, to have everything under the same place. So these are, anyway, fantastic points. I want to double check to make sure if there are any other questions that we haven't got to from the audience. But the other one that I wanted to ask is one of the things that comes up, or that comes up frequently with one of our members, that his favorite feature in Kubernetes are CRDs. Would you agree, or is there another feature that you might like more?
Yeah, excuse me. Yeah, CRDs certainly are very powerful in terms of being able to define your own specification, being able to leverage different API services for operators, being able to encapsulate logic and kind of build an abstraction for some of the primitives that exist in Kubernetes today. So yeah, certainly it's made things a lot more extensible. That being said, there's a lot of proliferation of custom resources. You know, there are custom, they fit specific niches, and you know, as we've seen with the operator landscape, like there's a ton of operators, and sometimes it's challenging to know exactly which one do I choose. How do I know an operator is so fully featured for my use case, and how do I kind of pick? So I think it has come with you know, increased power, but also with this this ability to have a lot of configuration. There's less. It makes it more difficult to kind of determine like the right best practice, the right opinionated default for customers that are onboarding to a specific application.
Great. And sorry, go ahead. Actually, yeah.
So sorry about that, Bart. So I think like Peter was on point, right? You have flexibility, like Kubernetes can like flex itself to like address like the organizational needs, the application needs, and CRDs really enable that. And that's beautiful and that's powerful. However, with obviously great power comes the responsibility of a larger surface area. So what we see customers do is they do have CRDs over time, and then they do shrink over time as well. So there is that proliferation, and then you have to prune it down as well to kind of say, okay, which one do I actually depend on? The operator I can maintain, the operator I can trust. And you have to go through that prune exercise because it's important, because you want to run like dependable and safe infrastructure. And so that's the only the trade-off and the nuance you need to like go through.
I think it's a great point. And also as well too, with both of you are saying that the decision-making process, if someone doesn't have experience with operators, can be very overwhelming because there are so many. And once again, as you mentioned previously, if I have to go to a customer and say, no, we trust this, it's reliable, it has a track record, we know the maintainers, that's going to take some time. You know, like that's not just going to, you know, fall from the sky necessarily. So I think these are the factors that go into it. Some things that have been discussed in the community have been, will there be one operator to rule them all in the future? Will there be some kind of a process for validating operators in terms of quality control? Are these some of the things that we can expect to see? And these are some of the questions that we'll be featuring in our next research report, because the operator pattern has been so strong. So we can expect to see more feedback from different organizations that we'll be interviewing for that in the coming months. That being said, we are just about out of time, but before we finish, just want to thank both of you. This is a fantastic live stream. Lots of questions, good interactions from the audience. I had a couple of comments about operators that I actually want to start a conversation about in Slack, just because, like I said, this is a very strong topic. Just want to thank both of you, though, for the wonderful presentation. And before wrapping up, as is tradition, we have our amazing artist, Angel, in the background, who's creating an artistic depiction of the topics that were covered. So we have this nice drawing that he put together showing the different things that were featured in the talk. Obviously, we covered a lot of ground. And as you mentioned as well, Peter, we'll be sharing the slides in Slack, and so that people can also take a look at what you were sharing in the demo. That being said, we've got plenty of stuff coming up next week. We've got a couple of live streams, as well as the in-person events in the Bay Area. So if anyone's around Mountain View, definitely stop by to check it out. Gonna have some really, really good talks, and of course, wonderful people to hang out with. So Peter and Akshay, thank you very much for your time today, and look forward to interacting with you soon.
Wonderful. Thanks so much, Bart.
Absolute pleasure. Take care. Bye-bye.